In this video, we're going to continue looking at the inverse normal function. So if you think you understood it from the last video, do pause the video and have a go at this yourself. The lifetime of a certain brand of bulbs are normally distributed with mean 150, 850 hours and standard deviation 50 hours. Find the upper and lower quartiles of bulb lifetimes. Okay, so let's think about what our distribution is. So there's a normal distribution, a mean of 850 and a standard deviation of 50, so I'll write 50 squared here. Now let's just visualize what's going on. So we have normally distributed data with a mean of 150, 850, and we're trying to find the upper and lower quartiles. Now let's begin with the upper quartile. We'll see why in a second I'm starting with that. But the upper quartile is the point, by definition, that has a quarter of the data above it. So this probability over here should be 25%. And, well, which is the same thing, there should be a 75% chance of landing to the left of that. So if I was to think about this in terms of the inverse normal distribution, what I'd be saying is the probability of landing to the left of that upper quartile, that's this whole region over here, everything up to that upper quartile should be 75%. If you go to your normal distribution table and you scroll down past the main table, you'll find this little box here, which is the critical values for the normal distribution. Now, it's basically a little table for the inverse function, but it only gives you a small number of values, and they're all on the right-hand side of the distribution. That is, the probabilities are all above 50%, just like they are here. So if you're looking for the 75% mark, i.e. the upper quartile, it just gives you the Z value there. Similarly, the 90% mark, which would be the top 10%, 95% of the way through the data, that's the top 5%, and so on. It gives you these nice round numbers. So it's actually probably quicker than using the calculator, although feel free to use the, either method. So for my upper quartile, right, the 75% mark, I can see that the Z value is 0.674. So I know that this upper quartile here corresponds to a Z value of 0.674. Now, let me just show you how we would do that on the calculator as well, because that's also a great way of doing it. We'd go to distribution, normal, inverse normal. We'd want an area of 0.75, standard deviation 1, mu of 0, and look, we get the same value, just with more decimal places. Okay, so what we can do then is say that if our Z value is 0.674, we know that the Z value is equal to the X value, which is our upper quartile, minus the mean, divided by the standard deviation. So we can now work out what the upper quartile is by simply taking the Z value of 0.674, multiplying by 50 and adding 850. And we get 883.7. Now, we could do the lower quartile from scratch as well, but actually we've got a nice shortcut. Because of the symmetry of the normal distribution, the lower quartile will have a Z value which is precisely the negative of the upper quartile. The reason for that is that 0.674 tells you go 0.674 standard deviations above the mean to get to the upper quartile. Well, therefore, you must go the same amount below the mean to get to the lower quartile. So we can find the lower quartile by simply replacing the Z value with negative 0.674. And then we just need to solve this equation here, and we get a lower quartile of 816.3. So that's how we find quartiles. Remember, you can use your calculator to check this directly. All we'd actually need to do is go back to our inverse, go with an area of 0.75, and we can actually just use the standard deviation from the question and the mean from the question, and we get our 883.7, and we could just change the area to 0.25, 25%, to get the lower quartile as well. Remember, this is a check. You need to show you're working to get the marks in the exam, but it's a great way to check. Let's have a look at another question. So IQ is known to have the following normal distribution. What must your IQ score be to place you at the 99th percentile? So remember, the 99th percentile is 99% of the way through the data. So that's the top 1%. So that's going to be a distribution with a mean of 100, and the 99th percentile will be way over here. There'll be some region over here that includes 1% of the data, and this is the mark. So let's just mark that with an X. So our job is to find the Z value that corresponds with the top 1%. Now again, we could do this with a calculator, but this is a great one to look up in the table, because if it's the top 1%, it's 99% of the way through the data. It's the 99th percentile, of course. So let's jump to the tables and find it. So in the tables here, you can see 0.99, so 99% of the way through the data, and the Z value is 2.326. Very easy to look up. So Z is 2.326, and now we can just solve our standardizing formula to find what that X value was, because it's X minus the mean divided by the standard deviation. That gives a value of 134.9. Now, what must your IQ score be to place you at the 99th percentile? Well, that's the answer. The question does not specify it needs to be a whole number. I don't know if IQ scores come only in whole numbers. I'm sure that would be acceptable, and I'm also sure that 135 would be acceptable as well. Now, just to show you how we could have used the calculator to achieve the same thing, in our inverse normal calculator, we just would have had an area of 0.99, standard deviation 1, mean of 0. That gets you that Z score of 2.326, which you can then use to find the X value. And remember, the check you can do is to actually just use the standard deviation from the question and the mean from the question, and look, you get the same answer as well. So that's the inverse normal function. I hope you enjoyed that. I'll see you in the next video.